Welcome to Ask and Learn.
Okay, so here we want to express the recurrence relation in terms of its backwards differences, right? And so we know that the backwards difference of a sequence is going to be equal to that sequence a sub n minus the sequence a sub n minus 1. And so we're going to go ahead and use this to determine the second difference, which would be expressed as the first difference of an minus that first backwards difference of a sub n minus 1. Well, so this is going to be equal to, just using the formula above it, an minus 1 minus an minus 1 minus a sub n minus 2. Okay. So this ends up equaling a sub n minus 2 a sub n minus 1 minus a sub n minus 2. Okay, so our goal is going to be to express an equaling an minus 1 plus an minus 2 in terms of their backwards differences. So we're going to go ahead and start from the derivation that we did here, where we have this second backwards difference being equal to this. We're just going to rewrite that. Okay, so that we get a sub n minus 2 on one side, and that will be equal to the second backwards difference of an minus an plus 2 a sub n minus 1, right? So I just subtracted an from both sides and added the 2 an minus 1 to both sides to get that. All right, well, so this, we can add a sub n minus 1 to both sides. Okay, so we'll get a n minus 1 plus a sub n minus 2 is equal to the second difference of an minus an plus 3 times a to the n minus 1. So that we, in this instance, we added a n minus 1 to each side. Okay, so on the right-hand side then, based on the derivation of the first difference, right, and the first difference, again, states, so we can rewrite this, right, to say that a of n minus 1 is equal to an minus the backwards difference of an. So we're just going to rewrite that and then plug in that value for an minus 1 here. Okay, so this gives us the second difference of an minus an plus 3 times an minus the first difference of an. And then we can combine these like terms, right? So we have an here and 3an here. And so that'll give us the second difference of an minus we can do plus 2an minus 3 times that first difference of an. Okay, and recall our first formula was to show that an equals an minus 1 plus an minus 2, which is what I have here. But to rewrite that in terms of the backwards differences, right, which we have here. So if we just want it to be a little bit more succinct, then we can say that an is equal to, since an is equal to a sub n minus 1 plus a sub n minus 2, it must be equal to the right-hand side. So it's equal to the second difference of an plus 2 an minus 3 of the first difference of an. And that is the solution.